Hey everyone, it's Mr. Petrano, and in this video we're going to go over two main skills that are going to be needed for our full understanding of ionic compounds. We're going to need to know how to name the compounds based on their formula, and then vice versa, provide a formula of the compounds based on their name. So there is a guided note sheet that you should find on Google Classroom. Follow along with me, and then you'll be submitting the practice questions for your follow-up assignment today. So I'm just going to share my screen and go to it. So to start, we're going to be working with binary ionic compounds. So binary just means two. So for a binary ionic compound means there are two elements in it, a cation, typically a metal, and an anion, typically a non-metal. So at this point in class, we discussed what an ionic compound is, how to formulate ionic compounds based on the valence electrons each atom gains or loses. So you guys went through that simulation and you kind of worked through that. So we're going to also focus on how to name these compounds. So the process is pretty simple. We just need to revise some pieces of their name. And we kind of already went through this a little bit. You saw this in that Ed Hustle video about electron dot diagrams. So as that video went through, we know that non-metal atoms, when they become the ionic version of themselves, they do that when they gain electrons, when they gain valence electrons. And in order to state that it is an ion and no longer an atom, we change the suffix of the name, so the last part of it. So typically, the elements have their basic name like hydrogen, chlorine, bromine, iodine, etc. And we're going to drop that ending and give it the ending IDE, ide. So an example is when we go from chlorine, the chlorine atom, which is neutrally charged, to the chloride ion. So it's anion, -1 charge. So this is common, proper nomenclature, so how to name these ionic compounds. So we need to make sure that we're following the structure. So I have down here just a list of various elements in their neutral atomic state, the name, and then the name when they become the ion. So like I just went through before, we have chlorine. Here, erase this, I'm sorry. So chlorine turns into the chloride ion. So when it gains that one more valence electron to fill its full shell, it becomes the ion, and that's just how the name changes. Bromine turns into bromide, iodine turns into iodide. So the naming structure is pretty similar. Some elements, the name kind of changes a little bit more. So like you have reference to this list. So keep this in your notes, write these down, do whatever you need to do with it. So like hydrogen turns into hydride. Now note, this is only when hydrogen becomes a negatively charged ion. So that's something just to keep in mind. Sometimes it is positive. Oxygen turns into oxide, sulfur, sulfide, and so on and so on. So for the most part, you'll see that they just drop the ending and go IDE. If you ever kind of get stuck on one, just like you can shoot it to Google, send an email, whatever. Now, to be fairly honest, I don't know why we do this. I've researched this to like no avail as to any reason behind this. There's a group of chemists that are known as the International Union of Pure and Applied Chemistry, what's known as the IUPAC. That term sometimes comes up in Regents questions. So if you ever see that, it's just literally people in charge of naming chemical compounds, elements, other types of research. I kind of like to call them the chemistry police. So they kind of just like make all the rules about this stuff. Once again, I have no idea why we do this. It's just common practice. And it's just something that we have to do and something I expect you guys to follow along with. So that's just what happens when the elements turn into their ions and how we change the name of these anions. But we need to also figure out how we are going to name a full ionic compound based on its formula. So we're going to go through an example, and there's really 3 steps, and they're very simple. So we're going to use KBr as an example. So we have the formula, and we want to write out the full name of this ionic compound. Now we know it's an ionic compound because it is formed between a metal and a nonmetal. So that's just a characteristic of ionic bonds and ionic compounds. So first thing we want to do is write out the full name of the cation, which is the metal. So in this case, K, if you check our periodic tables, we know K is potassium. So I'm going to write that K, potassium. Second step, determine the new name of the ionized version of the nonmetal anion. So we have bromine. Oops, sorry. Bromine is the name of the element. And as we said, we're going to drop the ending. So it's no longer bromine, and turn it into bromide. So the ending just changes to IDE. And then all we do, add them together. So we have potassium, bromide. And that's it. So all we did, take the metal, K, potassium, take the nonmetal, bromine, drop the ending, make it IDE, and put the 2 together. So that is the name of the ionic compound with the formula KBr. So that's all you have to do with that. Now, you may be familiar with things like CO2, and you're like, oh, carbon dioxide, and CO is carbon monoxide. We're going to get to that later on. But because these are not ionic compounds, we will get into like what kind of compounds they are in the next couple of weeks. We are not going to be using the prefixes with these. So no mono, tri, di, stuff like that. So when we're naming ionic compounds, so ionic, once again, the ones that are between metals and nonmetals, we are not going to use any prefixes that represent how many of each element are present. So an example here, we have Al2O3. That is just going to be aluminum, that's the Al, and oxide, that's the O3. So we won't say trialuminum dioxide or anything of that nature. So we are just simply sticking with the metal and the nonmetal when it is in its ionized name version. Okay, so that's how we go from formula to name. Now we're going to just take a minute and go through how we determine the formula based on the name. So we're kind of just like flipping it around. So I'm just going to scroll down, clear this. Okay. So now we're going to look at determining the formulas of ionic compounds. So as you guys also saw in that little simulation, ionic compounds are formed in crystals. And their formulas demonstrate the ratio of cations to anions. Now, this is because if I was to take like a salt crystal, so regular table salt, you may be familiar, is sodium chloride, NaCl. So if I was to take a look at one of those salt crystals at a like atomic level microscope, I wouldn't just see 2 atoms. I would see a whole crystal of 3-dimensional form of multiple sodium ions and multiple chloride ions. So this crystal, just kind of the formula of this crystal, this represents the ratio of the positively charged ions, so sodium in this case, because it's the metal, compared to the negatively charged ions, the chlorine, the chloride. So, and that's because if I look at any 2 salt crystals, they're also going to potentially have different sizes. So one might have like 1 million sodium ions, where another has 2 million. Simply, size just happens to vary between these crystals, but the ratio between the positive and negative ions always stays the same. So really, in order to determine the formula of a compound, we just need a couple things. So this is also pretty simple, pretty straightforward, just a few steps. So we need to know which element is the cation and anion, which we can determine simply from looking at the periodic table. And we need to also know their respective charges. So the charges with a number. So +1, -2, whatever it might be. So we're going to go through these 3 steps using calcium chloride as an example. So step 1 says identify the metal cation and non-metal anion. So calcium, we know, is a metal. It is Ca. It is in group 2, so it's on the left side of the periodic table. And then chloride is our non-metal. So we can tell it has the IDE, so it must have been chlorine, and then we turned it into chloride. So that's the one that is the anion. So I'm just going to jot in here, metal is Ca, and then the non-metal is Cl, so calcium and chlorine, or chloride ion we're going to look at. Okay, step 2 says we need to determine the charges of both the cation and anion. So this is where we're going to look at how each of these atoms can achieve the noble gas electron configuration. So we're going to look at how many electrons are gained or lost into this. I'm just going to clear this so I can scroll down. Sorry, the words don't move with my document as I do this. So I'm going to have to clear things as we go sometimes. Okay. So calcium has the configuration of 2, 8, 8, 2. So we have 2 valence electrons. It's in group 2. And in order for it to look like the closest noble gas, it wants to lose those 2 electrons. So it's going to get rid of those 2. And because it loses 2 electrons, it becomes calcium with a +2 charge. Which again, we lose electrons, we get a positive charge. Chlorine has the configuration of 2, 8, 7. So it's only 1 away from turning into the next closest noble gas. So we're going to add 1 valence electron. So this now becomes 288. Because we gained an electron, chlorine is a -1. Once again, calcium loses 2 electrons because it loses those to become the noble gas. So it's +2. Chlorine has 7, so it needs 1 more to become the 288. So it is chlorine with a -1 charge. So, and this kind of like goes back to our initial statement. We know calcium is the metal, so it must be the cation. Chlorine, chloride is the non-metal, so it's the anion. Okay, so we know the charges. Now, third step, we need to balance them. So essentially, we need to know how many of each ion are required for this charge to be neutral. So in this ionic crystal, we need to know the ratio of calcium ions to chloride ions. Now, there's 2 methods to this. One kind of goes through it in a few more steps and a little bit more slow to work through. And one is kind of like a quick method to go through this. I've seen students use both, and like several students like one, several like the other. So I'm just going to go through both, and you guys can figure out which one you prefer. Okay, so the first one I call adding up the charges. I don't really know like another name for it, so you can call it like the original way or something. So what we're going to do is essentially put down 1 calcium ion. So calcium, we know, is a +2. And then we're going to put down 1 chloride ion. And do a different color. So 1 chloride ion, which we know is -1. Now, if I add the charges up, +2 and -1, I still have 1 extra positive charge. So +2 plus -1 gives me +1. So currently, we are not neutral. So there's a way that we have to fix this. So if we have one extra positive charge, then we need an extra negative charge to try to cancel that out. We'll see if it works. So let's clear this. So once again, we had an extra positive charge. So I'm going to add one more chloride ion here and see what this does. So now we have +2, -1, and -1. So we'll see if this bounces out. You might see, oh yeah, that should. +2 plus -1 plus -1. Add these up and you get a neutral charge, 0. So what this says is that we need 2 chloride ions for every 1 calcium ion in order to balance out the charges and make it a neutral compound. That is going to help us get the formula. Another method we can use is something called the crisscross method. So what this entails is looking at the charges of each ion, lining up just like this, and then dragging the appropriate numbers from the top, so the charge is up here, and forming a subscript. Subscript just tells us how many of each atom are in this formula. So I take the +2, I'm going to circle just the 2, and drag it down to here. And then same thing with the chloride. Chloride is -1. I'm going to circle just the 1 and bring it down to here. So this ends up looking like calcium 1, chloride 2. And then much like we've gone over previously, if there's a 1, we can usually just kind of leave it out. It's actually appropriate to leave it out in this case. So this also kind of tells us that for every 1 calcium ion, we need 2 chloride ions to balance out the charge to make it a neutral atom, a neutral compound, I'm sorry. So 2 ways to give you kind of the same thing. And then our formula for calcium chloride, sorry, I'm just going to have to clear this and scroll down, is going to be CaCl2. Now we got this from both adding up the charges as well as using this crisscross method. So once again, whichever you like to use, totally up to you. Okay. So we've gone through this. Now there's some practice on the following page. You're going to state the name of some compounds as well as create the formulas of some. And that'll be just the rest of your assignment for this follow-up. All right. Reach out to your teacher if you have any other questions.